All right, section 12.3, measures of dispersion. Okay. We're going to talk about the range and standard deviation. Okay, range. There's a difference between having, let's suppose I gave a test. I was looking at test scores, and every single person in the class had a test score between 75 and 80. Okay, so 75, 75, 76, 76, 76. Every person in the class had a test score between 75 and 80. That's a very small range for the test scores. On the other hand, that actually doesn't happen very often, but let's suppose we have a class and the scores range from the lowest test score is a 0, the highest test score is 100. That would be a huge test score range. So either of those situations would tell me something about the test, okay? So that's range. To figure out the range, we're going to take the highest number data value and subtract the lowest data value. In this particular example, it says Honolulu's hottest day is 89 degrees, coldest day is 61 degrees. So if we take 89, excuse me, subtract 61, it has a temperature range of 28 degrees. Which is actually pretty narrow. Honolulu tends to have a pretty narrow temperature range. Okay, computing the range. The figure shows the age of the 4 oldest U.S. presidents at the start of their first term. All right, so find the age range for the 4 oldest presidents. Okay, so we are going to take the oldest president at the start of the first term, which is President Trump, and he is 70. And we are going to subtract the 4th oldest president at the start of his term, which was Buchanan, and he was 65 when he started. And if we subtract those two, we have an age range of 5 years. All right. So another thing we can talk about is what's called the standard deviation. Okay. Standard deviation has a lot of steps, So we're going to kind of take it step by step. First thing we're going to do is figure out how far away from the mean a particular data item is. We're going to do that for all 4 data items that we have. Okay, so step 1, we have to calculate the mean. We're going to add up the scores. We have 4 scores. We're going to divide it by 4, and the mean is 68. Okay, now the deviation, not standard deviation, but just deviation from the mean, we're going to figure out how far away each of these data items is from 68. So we're going to take 70 and subtract 68 and get a deviation of 2. We're going to take 69 and subtract 68 and get a deviation of 1. And we're going to take 68 and get 0. And we're going to do 65. Oops. Well, okay, here we go. 65 subtract 68 gives us a -3. Now, standard deviation, what we're trying to figure out is how far away, on average, each data item is away from the middle, the mean, okay? If we were to just calculate the deviation, deviation from the mean, data item subtract the mean, and then add these up, this being negative is going to kind of mess it up for us, okay? So while this is technically -3 years away, we don't want that negative to kind of mess up our process, because we're really kind of trying to figure out that it's 3 units away, not necessarily that it's -3 units away. So um, deviation from the mean, we're just going to straight up subtract the two numbers. Find the mean and take the data item and subtract the mean. Okay, so that is called deviation from the mean. That's the first step. Let's go to the next slide, and it's not going to the next slide. Let's try it. Okay. Well, actually, step 2. Okay, so a lot of steps, not kidding, but each one of these is just simple arithmetic. All right. So the first one is find the mean. We know how to do that. Find the deviation. So we're going to take the data item and subtract the mean. Okay, now this next step is going to help eliminate, remember how I said there was a problem with that data, with the deviation being -3 instead of +3? By squaring it, that will make everything positive. So that will help take into account, being on one side of it versus being on the other. Okay, so we're going to square those deviations that we found, and then we are going to add up those deviations, and we're going to divide by 1 less than the number of items that we have. So you can think of it as kind of finding an average. Right now we're finding the average of the squares. We're not dividing by n, we're dividing by n minus 1. Don't ask me why, it's a statistics thing, and to tell you the truth, I don't know, but this is the formula we use. So it's n minus 1, not n. So find the deviation, square the deviation, add them up, divide by 1 less than the number of numbers we have. But because we squared stuff, we have to unsquare it, meaning we have to take the square root, okay? So this will give us the average distance away from the mean for each data item. And what that means is it gives us an idea of how spread out our data items are. Are they really super close together? We would have a standard deviation of a very small number, or are they really far apart? We would have a very large standard deviation. Okay, so we already found the mean, that was 68. We already found the deviation. Now what we're going to do is we are going to square each of these numbers. We're going to square each of these deviations, okay? So squaring turns everything positive. So we take 2, we square it, we get 4. 1 is 1, 0 times 0 is 0, -3 times -3 is 9. Once we've squared them, keep in mind that we are trying to find the average distance from the mean, so we are going to add these up in preparation for finding the average. So we add these up and we get 14, okay? So that's what this notation means. We're going to take the data item, we're going to subtract the mean. This is notation for mean. Data item minus the mean. Add them up, okay? If we were to add them up, we would get 0. That doesn't really tell us what's happening. So instead of adding up the deviations, we're going to add up the square of the deviations, and we get 14. This means add them up. Add up the squares of the deviations. Once we have added them up, we're going to divide by n minus 1. Don't ask me why we don't divide by 4, because we have 4 items. I really don't know the answer to that. So we have 14, and instead of dividing by 4, we're going to divide by 4 minus 1. So we have 14 divided by 3. That will give us a decimal. We're going to hold off on finding that decimal. And then to find the actual standard deviation, final step, we're going to take the square root. So we have to unsquare all of that stuff that we just did. So we're going to take the square root of 14 divided by 3. Okay, so this is where we put it into our calculator. We take 14, remember, inside, work your way out. So inside is the 14 divided by 3. And then we are going to find the square root of that number. Let's see. And we get, let's round it to 2 decimal places. 2.16 is approximate. It's pretty common to round standard deviations to 2 decimal places, but just go by what they tell you. If they say 2 decimal places, then do 2. If they say 3, then do 3. Just whatever they tell you to do. All right, again, you're going to hold off on turning this into a decimal until the next step after you take the square root of it. And that's how you find the standard deviation.